Shalom to you and welcome. In this video, we will be using the trig ratios to solve real-world application problems. Okay, so we apply the concept we have already learned to real life. One of the major applications of this trig is finding angle of elevation and angle of depression. So what are they? Angle of elevation and depression. Think about the word elevation means up, going up. Depression means down. Okay, so let's use this illustration to understand angle of elevation and depression. So when you're looking for angle of elevation or depression, the horizontal line is your reference line. So horizontal line is always parallel with the x-axis. It's flat on the floor. Okay, so if we have like these, something like this, make a zigzag. So the angle of elevation has to make reference with the, if you start from the horizontal line, it's gonna go up to touch the line. Okay, so let's say this is like point T, and this is like point H, and this is like point F. Okay, bring that, and this is like point. All right, that should be enough. Maybe A, B, C, D, maybe A, doesn't matter. They're all variables. Okay, so we look at this. This is a horizontal line. This is a horizontal line. No matter where the horizontal line is, whether it is up or down, it doesn't matter. Just start from the horizontal line and make angle. So if somebody, standing here at H, between H and looking at T, somebody standing at H and looking at T, or standing at T and looking at H, either way. Either somebody is up and looking down, or is down and looking up, you see. So if somebody is standing at, let's say somebody is standing at H as T looking down to H, so he's looking down. So the eye is going to make the contact from the horizontal line to this line of sight. This is the line of sight. The line of sight is TH. So the person is looking down. So you're going to make an angle from the horizontal line down to connect to this. So that's the angle of depression. It's looking down. So it's the angle of depression. Even though it comes from up down, but it's going down. The sight is going down from the horizontal line. So it's the angle of depression. We look at this angle here. What is it? Is the angle of elevation or depression? We start from the horizontal line. If we start from the horizontal line, we are going to draw our pen is going to go up to connect to HT. See, we are going up. So it's going to be angle of elevation. Angle of elevation. Because it went from floor up to get to the line of sight. Okay, let's another one. So how about this? And that's the horizontal line. What type of angle is this? In reference to FA, it's going to be angle of, from horizontal line, we drew our pencil, went down, go down. So it's the angle of depression. And this, so horizontal line going up to touch the line is going to be angle of elevation. Okay, so yeah, so let's use that to answer questions. They have good one in your book here. Okay, so we look at this. Okay. So here two people at X and Y. Here's X and Y. There's somebody here, somebody here. And they are looking at a plane at this point A. So each one of them make a line of sight. This one makes a line of sight, YA and XA. Okay, so what is the angle of elevation from X to A? So looking at angle of elevation from X to A, okay, I will draw that so I can write on the paper. So the angle of elevation from X to A. So this is X to A. x to A. So we start from the horizontal line and make our angle from horizontal line to line XA. Our pen went up. See, it went from down to up. So angle of elevation is 35. And then next, what is the angle of depression from AX? Again, AX, the same line, AX. So from AX, from A to X, somebody standing at the plane going down, A to X. So we have to make an angle from that horizontal line until we get line AX. So we are coming down to AX, to this line. So we have those two angles together. So it's going to be 23 plus 12. And that's going to give us 35. It is also 35. And if we notice, those two angles, the sum of those two angles is alternate interior to those two angles. So they are equal. Okay? But the angle of depression is 35 there. Here, what is the angle of depression from A to Y? AY. So we go to Y. Okay, the A to Y. So angle of depression A to Y. So we start from that horizontal and draw our angle to end at AY. So it's 23. See, makes angle 23. See, what is the angle of elevation from Y to A? From Y to A, so angle of elevation, we start from the horizontal and draw our line until touch line YA. So right there. So what angle do we have? Well, wouldn't that angle be, because both of them start from the horizontal line and touch AY, this starts from horizontal line and touch AY, so it's going to be 23 also, because they are alternate interior angle, they are equal. Okay, see how that knowledge we learned in chapter 3 comes to play. Okay, the question asks, is the measure of the angle of elevation from Z to A, greater or less than 35? Okay, so let's draw an angle from Z to A. If we draw a line there, so he asks about the angle of elevation. It has to be elevation, so elevation has to go from horizontal up. So we're talking about this angle. Okay, how do we respond to that? Pause the video and try to figure that out. So if we notice from the pattern of the ones we've done before, see, Y is farther away from A. If we draw, a vertical line down here, makes a 90-degree angle. So that's gonna be the shortest length but the highest angle. So if the farthest away is the longest side, it was gonna make a smaller angle. You see, X is closer to the 90, this side. So this line is shorter, but the angle is bigger than this angle. So the angle here, this line is going to be shorter than this one and this one. So the angle is going to be bigger because it's going to get closer and closer and closer and closer to 90 degrees. So it's going to be greater than 35. All right, let us solve some more problems from your textbook, page 319. All right, look at this one. Seems like a good one. Okay, and they encourage you to draw a diagram, and I very much encourage that as well. So it says an advertising blimp hovers over a stadium okay, let's draw a stadium. So let's just zoom in the stadium like somewhere there. Stadium somewhere there. Hovers over a stadium. Okay, at an altitude. Now, altitude means height. So there's going to be a vertical line straight up down. The altitude is 125 meter. Okay, so the altitude is going to make, this is the ground. It's going to make a right angle with the ground. Okay, the altitude is the height. You're gonna make a right angle with the ground. So this is the horizontal ground, and it says the pilot sights a tennis court. So the pilot is up here. It's up here. It sights a tennis court at an angle of depression. Okay, so it has angle of depression, so we're going to make another kind of horizontal line there. It's up there, but to be able to connect to the line of sight. So you make angle of depression, so it's gonna go like that because it has to make a right go from the horizontal down. Draw it from horizontal down. So it can go, drawing from this one will be going up, so angle of elevation. So it's gonna go from up down. The pilot is here looking down. So this angle is 8 degrees. Make that angle 8 degrees. I'm going to find the ground distance at, so he's looking at the tennis. So the tennis is right here. So the tennis is at this spot. Looking from the pilot, looking down at the tennis. To find the distance between the stadium and the tennis court. So the stadium and the tennis court, so it's looking at this distance right here. You're looking at the distance from here to there. Okay. And it asks us to note in exercise that is saying about 100 meters. So they ask us to round to the nearest 100. So we keep that in mind. Round to nearest 100. Okay. All right, so now we have our picture. We're going to look at how to solve this problem. Well, we look at this triangle. We do not know the angle here. We don't know the angle here. So the two acute angles we need, we don't have them. Let's see how we can use what we have to find them. Well, this angle of depression here, 8, because the two horizontal lines are parallel, always parallel. So it's going to be alternate interior to this angle of elevation here. So that's going to be 8 degrees as well. And so with that, let's see if we can, what connects. This is the hypotenuse. This side is the hypotenuse. Because the right angle is here, it's opposite right angle. So what is opposite angle 8? 125 is opposite angle 8. D is adjacent. So the SOHCAHTOA. So which one has opposite adjacent? Opposite and adjacent is TOA. So it's tan. So we're going to find tan 8 degree was opposite over adjacent. Again, tan, it connects the two legs. If you notice, these are the two legs because they join together to make a right angle. So tan is 125 over D. So, but we're solving for D. So first of all, we need to multiply D by both sides to get it out of the denominator. So this is D times tan 8 is equal to, let's cross this out, 125. So next, what do we do to get D by itself? These are held by multiplication. So we divide both sides by tan 8. So that gives us 125. Find tan 8 with your calculator. 8 tan 0.1405. Okay, 0.1405. Now if you have store, you can use store, but for the sake of those who may not have store, let's just do it up normally. So you need to kind of erase and then type back in 125 divided by 0.1405. Okay, then 8 it gives us like about 889.6. Again, they ask us to round to the nearest 100. So which number is in the 100 place? This is ones, tens, hundreds. So it's 8. So we want to round to the 8. We have to look to the right. This next number is up to 5. So we have to borrow 1 from there and add on. So that gives us approximately 900. So the rest becomes 00. So D is approximately 900 meters. Okay.